Yes, student, here is one of the question from the NCRT. What can be inferred from the magnetic moment values of the following complex species? Now, student, complex species is introduced here, but we haven't read a lot about the complex species in the present chapter. The complex species, that is the coordination compound, are introduced in the next chapter, that is coordination chemistry, and therefore in this time the answer of the question becomes little difficult. It will become easy when you will study the next chapter, what coordination chemistry, but here it becomes little difficult. Very first we have to understand what is the meaning of the question. The meaning of the question: the magnetic moment of 1, 2 and 3 compounds are given here. This is the experimental value, that is approx magnetic moment is this one. On the basis of the magnetic moment value, which type of information we are getting about these complexes, that is which type of complexes are there, what will be the hybridization state, or the ligand introduced here like cyanide, water and Cl will belong to strong ligand field or will belong to weak ligand field. And the detailed knowledge of this type of knowledge, detail of all this knowledge is given in the coordination compound chapter. However, I am trying to explain, okay, and when we will read about the coordination chemistry, again I will explain the question. Are you getting? Students, so to solve the question, what we have to do? Actually, very first we have to find which one is weak or ligand filled out of this given ligand. So first we have to find the number of unpaired electron. As greater the number of unpaired electron, it will stand for weak ligand, and if there is lesser number of unpaired electron, it will stand for strong ligand, because strong ligand can pair up the unpaired orbital. So if the unpaired orbital will pair up, then lesser number of unpaired electron will be there. So what we have to do? We have to find the magnetic moment in case of number of electrons is 1, 2, 3, 4, 5, etc. Are you getting? So using the magnetic property and the formula mu, it is equal to root n into n plus 2, where n is called number of unpaired electron. Number of unpaired electron. So let's start by placing the value of n, and then we will match with this one, that is the given value. Then we will find which one will have how many number of unpaired electron. So if n is equal to 1, then it will become what? Root 1 plus 2. Okay, it is equal to root 3, and root 3 is equal to 1.73. Okay, in case of n is equal to 2, then it will become what? Root 2 into 2 plus 2 is equal to what? 2 2 is 4, 2 4 is 8, that is what? Root 8, and the value of root 8 is 2.83 Bohr magneton. In case of n is equal to 4, then it will become root 4 plus 2, it is equal to root 4 into 6. So 4 into 6 is equal to root 24, and root 24, it is approx 3.9 Bohr magneton. In case of n is equal to 5, then it will become root 5 plus, multiplied by 5 plus 2, it is equal to root 5 into 7 is equal to root 35, and it is equal to what? 5.9 something. So student, in case of Bohr magneton is 1.73, That means the number of unpaired electron will be 1. So now let's check the first case. Question number first. In K4 Mn CN6. Okay, Mn is in +2 form, that is +2 oxidation state, but its magnetic moment is given what? 2.2, which shows that it has only one unpaired electron. It has only one unpaired electron. That means what? That means if we write the configuration of Mn, it will be what? It will be D5 and what? S2. This is D5, 1, 2, 3, 4 and 5. But when it will convert into Mn2 cation, its configuration will remain only what? D5 configuration. This will be its configuration. But the problem is what? Problem is that its Bm is, what is its Bm in the question? 2.2, which shows, okay, I have already written here, which shows that it has only one unpaired electron. Means what? That is what? Cn ligand is paired up its unpaired orbitals. Now, if it will pair up its unpaired orbital, means what? Means this orbital is paired by this one, this is paired by this one. So now the new configuration become what? Here will be paired, here again paired and here unpaired. So these unpaired orbital, so new configuration is this one, okay, which shows that Cn ligand is strong ligand field.